Okay, so we're going to move on to the next section. Our next section here is going to be talking about the section number 5.6, which is Law of Cosines. The standard that's attached to this is PC.G.4. So in that case, we're going to talk about the proof, the derivation for the Law of Cosines. Okay, so given a triangle that looks like this, very similar to what we had before, we have this relationship which is including cosines in it. So in that case, a squared plus b is equal to b squared plus c squared minus 2ac cosine a. B squared is equal to a squared plus c squared minus 2ac cosine b. And then c squared is equal to a squared plus b squared minus 2ab cosine c. Okay, so these are the relationships that can be created based on this triangle that we have before us. Okay, so when you apply this, you apply it for the SAS triangles, side, angle, side, and side, side, side triangle. So as long as you have three sides, 1, 2, 3, you can rearrange the equation to figure out what my angle is. So in case if you know what a squared, b squared, and c squared is, you know a and b, a and c, like you just isolate a and solve for what a is. Okay, if you have side, angle, side, that means this, this, and this. So you can just plug everything into the equation. You can find what your side is. And the rest, usually you probably need to use the Law of Cosine equations twice to get all the answers you need. Okay? So for today's lesson, I'm going to talk about the derivation and the proofs. So here we go. So given a triangle that looks like this, okay, so let's start off over here at this point here. This point here is going to be a distance. In that case, it's going to be c comma 0. That means that's the distance from 0 comma 0 to c0. So that distance here is equal to c. Okay, and now my height here is going to be something we have to figure out as well. But for now, let's just call this point here x0 comma 0. That just means the distance from here to here. So that means if you redraw this triangle, you get this triangle over here. So at this point here, we have x0 comma 0. And at this point, let's just finish this point here. So that means at this bottom of over here, that means going from 0, 0. Okay, let's write that. 0 comma 0 to this. That means my total distance here is equal to x0. Okay, that's my distance over here. Now, my height over here, same thing I should label here, is my x0 comma y0, and I'll tell you why in a bit, x0 comma y0, because the distance here is my x, so that means my x is the same thing as the x over here, but what we need to figure out is my height. So since if this is y0 minus 0, that means my height in this situation is equal to y0. Okay, so what we need to do now is rewrite our angles here, but our relationships. So that means I should also label this part here A as A over here. So we want to use this angle and use sine and cosine to derive the components we need. So that means if we have, let's use sine. Sine of B is opposite on hypotenuse. So that means it's going to be y0 over A. So if we want to get y by itself, you end up with y0 is equal to a sine b. Okay. Now, if we use cosine now, cosine of b is equal to adjacent on hypotenuse. So you end up with x0 over a, which implies x0 is equal to a cosine of b. So what we have here now is we have the coordinates for x0 and y0. So you can just go ahead and substitute that in. So that means we have a cosine of b, comma, a sine of b. And at this point here, we end up with a cosine of b, comma, 0. Okay. Now, we'll have to use these coordinates to help us figure out to derive the equations for this one. So given for this question, I'm going to derive b squared is equal to a squared plus c squared minus 2ac cosine b. Okay. So to start this proof off, let's just redraw the triangle we have over here, this triangle over here. So that means this point here, we have angle A. This point is going to be c comma 0. At this point here, we have, just copy what we have here, a comma cosine of b, comma 0. And then we have a cosine of b, a sine of b. Okay? So let's just say, let's call these sides, oh, we should just label this one. This one's b. Okay, since this is Pythagoras, this is a right triangle, we can use Pythagoras Pythagorean theorem. That means side 1, side 2, we can establish identity that s1 squared plus s2 squared is equal to b squared. Okay, so in this case, we're going to figure out what our side 1 and side 2 are, and square it, add them together, you should get b squared. But before we do that, we need to figure out what s1 is. So in that case, s1 is equal to, we have to use the distance formula. That means this minus this or this minus this. Either way is fine. Let's say c minus this, so to take the square root of x1, the identity of the distance formula is equal to x minus x0 squared plus y minus y0 squared, and whatever you simplify, that's going to be my distance formula. So this is what we're going to use. So point, let's just say c minus a, that. In that case, you have c minus a cosine of b squared, and 0 minus 0 squared. So in that case, 0 minus 0 squared. So you simplify, you get the square root of c squared minus plus a cosine squared b minus 2ac cosine of b. Okay? Now, let's go find what s2 is. s2 now is going to be this value over here. So it's going to be this, well, let's do my x's first. So in that case, a cosine b minus a cosine b. In that case, you end up with 0. So a cosine of b minus a cosine of b, whole thing squared, plus, in this case, this value, a sine b minus 0, a sine b minus 0. So simplifying gives us the square root of 0 plus this thing by itself. So in that case, it's a squared plus times sine squared b. Okay, so we have everything we need, and all we have to do now is figure out what s1 squared plus b2 squared. If you add them together, you should get b squared. So let's just say b squared is equal to, let's go ahead and simplify this. Okay, so if you s1 squared, you just take the square root and get rid of it, so you end up with c squared plus a squared cosine squared b minus 2ac cosine of b, and then you end up with this one, but when you square root, you can undo the square root, so in your case, plus a squared sine squared b. Okay, so the next step we have to do is probably factor something out. So in that case, let's put all the a squares together. You end up with c squared plus a squared. So the first one is cosine squared b, and the next one is 2 sine squared b. No, a squared sine squared b, so in that case, sine squared b. Okay, we got this one and this one figured out, and we just have this remaining one. 2ac cosine of b. Okay. Now, the next step here is sine squared plus cosine squared is equal to 1, so you can rewrite this as c squared plus a squared times 1 minus 2ac cosine of b. Now, this doesn't look exactly like this one, so we can just go ahead and rewrite this, get what we want. So in that case, it's a squared plus c squared minus 2ac cosine of b. Okay, and here we have successfully proved this identity over here. So the law of cosine, and this is the proof for it we have over here. Okay, you can rewrite the angles, mix them up a bit. You can derive what a and c squared is, and all you have to do is just switch it up a bit. So in that case, if you put c over here, you're going to say for c. If you move your a over here, and you have a over here, and just go through the same process, you will derive a squared, b squared, and c squared for these identities. Okay. There are other parts of this type of triangles. For this one, it's an acute triangle. If you have like a obtuse triangle and a right triangle, it's going to be a little more difficult to prove. So I'm just going to focus on this one. Okay. So all I have to do today is just take notes, and you're good to go. All right. See you on. Have a good spring break. I'll see you guys when I come back. All right. See you.